Good afternoon, all. Hope you are doing good. Okay, let's start today's class. So, in the previous class, we just concluded our discussion with human-computer interface. That is, the first module has been covered. So, we'll move to the second module now. Just I'll share the notes. Wait for a while. Yeah. The next module is computer hardware requirements for real-time applications. Yeah. In this particular topic, we will involved or required to design a real-time application. So first and foremost is the general purpose computer. General purpose computers are nothing but they perform general purpose applications. Like we have many series like Motorola 68 double X. That is 68 series controllers are the Motorola one. National semiconductors have the numbers starting from 32XX series, and Zilog Z80 and Z8000 series are examples of general purpose computers. A characteristics of computer used in control system is that they are modular. That is, they provide the means of adding extra units. They are modular. Modular means they provide the means of adding extra units. You can add the number of units required for your application. The overall performance of the system depends on the capabilities of basic unit in terms of its processing power, storage capacity, input-output bandwidth, and interrupt structure. The performance of the system depends upon the capabilities of basic unit in terms of processing power. How well your processor can process, or usually the processing is measured in drystrons. Processing power is measured in drystrons. Dijkstra coined this term dystron, which is the measure of throughput of the system. Any throughput, any computer system is measured in terms of its throughput, and the unit is drystrons. DHRYSTONS, drystrons. And we have the famous Dijkstra algorithm. The same person Dijkstra coined this throughput uh, throughput unit. The schematic diagram of general purpose digital computer is as shown in the figure. It is as shown in the figure. So this is your general purpose computer. The figure is missing here. Okay, fine. Any general purpose computer will have the normal CPU, central processing unit, then the registers, general purpose registers, then the memory. General purpose computers include arithmetic logic unit. Usually CPU comprises of ALU, arithmetic and logic unit. Control unit, CU, usually controls and coordinates for the various operations of the computer. Register, indefinitely. Memory, it can be RAM or RAM. Again, if I speak of RAM, they have random. They are called as random access memory. ROMs are nothing but read-only memories. They comprise memory and the input and output units. Now, if I go in detail of CPU, so if it is a CPU, the major block of CPU is the arithmetic and logic unit. Along with the control unit and general purpose registers together will comprise, or CPU is comprised of the following things: ALU, control unit, and general purpose registers. ALU contains the circuits that is necessary to carry out the arithmetic and logic operations. For example, computer will perform addition, subtraction. Then how the multiplication is done? Multiplication is done using successive addition. Suppose if you multiply 2 into 2, the answer is now 4. We'll have the tables, we'll multiply it, 2 times 2 is 4. But computers will add them. Successive addition is done. Successive addition is carried out by the computers to multiply, and successive subtraction is for division. So I'll show you a video how the computers will add and subtract. Just watch this video. So very important, or the very basic fundamental structure of any computer successive addition subtraction by computers. So just you can see here, I want to show you just simple video. Just I'll unmute.
For this video is again addition and subtraction, but in this video we are going to deal with the flowchart for these two operations. Now this flowchart is basically divided into two parts: subtraction and addition. Again we need two numbers A and B to perform both the operations. If you remember, in the previous video we made a table for signed magnitude numbers, right, where the addition and subtraction operation actually depended on the sign of the two numbers. So in this case, to find whether subtraction will be performed or addition, we need to check if the sign of the two numbers is same or different. For that we are going to perform XOR between the sign bit of the two numbers. AS and BS are the sign bit of the two numbers, and what we are doing is performing XOR. The result of XOR gate is given here. That means if the sign of the two numbers is same, the result of the XOR gate will be 0, otherwise it will be 1. Now if you see the previous video, you can see for the addition operation, when the sign of the two numbers were same, that is the first and the fourth case, the addition was performed. That is for 0 0 or 1 1, where the value of XOR gate will be 0, that is 0, addition is performed. Here the XOR gate results in 0, that is the sign is same. For add, that is the first and the fourth case, and addition will be performed where addition of A and B is performed here, and the result is stored in EA, and the value of E was transferred to AVF, and where AVF was add overflow flip-flop. In the second and the third case, where the sign of the two numbers was different, subtraction was performed. So what we are doing here is, in these two cases where the sign bit is different, XOR gate results in 1, and it will going in the subtraction part. Similarly for the subtraction part, if you remember, when the signs...
Okay, this is how the addition and subtraction is done to addition and subtraction is used to it is done in your computers. Computers will use the successive addition to multiply and successive subtraction to divide two numbers. So once this is clear, we'll move further. Yeah. This is how the addition and subtraction is done. Then we'll move to the next topic, that is we are discussing this general purpose computer. The ALU contains the circuit necessary to carry out arithmetic and logic operations, and also contains hardware units to perform multiplication, division of fixed point numbers. So if it is fixed point numbers, it's very easy, and if it is floating point arithmetic, again the job of the ALU will be difficult. The job of the ALU will be very difficult. Uh, Earlier computers had a limited number of general purpose registers. General purpose registers, it can be used for storing data temporarily, that is while it is being processed. General purpose register, it can be used for storing data temporarily, that is we can store the data temporarily. Early computers had very limited number of GPU. Most of the computers now have CPU with many general purpose registers, and hence many computations can be held in CPU without frequently accessing the main memory. So most of the computers now have CPU with the many general purpose registers, and many computations can be held in CPU without frequently accessing the main memory. The control unit continually supervises the operations within the CPU. It fetches the program instructions and from main memory, decode the instructions and sets up the necessary data paths and timing cycles for execution. Usually, the control unit supervises the operation of the CPU. So whatever operation is been done by CPU will be supervised by control unit. The features of CPU which determines the processing power are as follows. First one is the word length. Second one is the instruction set. So what about the word length? Word length depends upon the uh, processor word size. If it is 64-bit system, then the word length is 64 bits. If it is a 32-bit system, the word length is 32-bit. Likewise, it is machine specific. So it is machine specific. Some machines will have work with 32-bit arithmetic, and some will work with 64 bits. Likewise, instruction set. How many instructions are available for different operations to be carried out? That is what is the feature of the CPU. Then addressing method. What type of addressing method the CPU will follow? Whether it is direct addressing method, indirect method, or indexed addressing method. Likewise, we have many addressing methods. Which one is the best one? Best for your architecture. For the architecture of CPU is recommended. That is a important feature of CPU. And the number of registers. Number of registers required are how many registers are available for the computation of data or the storage of data. That is also one of the important feature of CPU. Information transfer rates. How well the information is transferred from one place from one system to the other system, or how well the CPU is capable of transferring the information. Next is the interrupt structure. Very important thing is interrupt structure. What is an interrupt? Interrupt is nothing but the unwanted signal, or not. It's not like that. Interrupt in general it is an unwanted signal, but usually in system language or in the computer systems, interrupt is the one which stops the execution of the main program. So once the execution of the main program is stopped, whatever interrupt has been raised, the computer will, or the CPU will go to the that program which caused the interrupt. So interrupts are, again, if I explain interrupt, it is a very beautiful concept. Like any real-time system will, the basis is interrupt. Suppose something happens to the system, then only the system will respond. Normal systems, we are not bothered. For example, time, a watch, a digital watch will keep the time, that's it. Whereas a fire alarm system will alert us when there is fire. What I mean to say is, have occurrence of fire is important. That is an event, external event will cause the system to respond. That is an interrupt. Interrupt fire alarm signal or the fire alarm sensor is an input interrupt to the system, which will set our alarms. Likewise, if I in the next classes, I'll be explaining the interrupt structure in detail. So these are some of the important features. First one is the word length. Second one is instruction set. The third one is addressing methods, number of registers, information transfer rates, interrupt structure. The basic instruction set of the CPU is also important in determining its overall. Hello, is there any doubt? Okay. The basics instruction set of the CPU is also important in determining its overall performance. Features which are desirable are flexible addressing modes for direct and immediate addressing, relative addressing modes, address modification by the use of index registers, instruction to transfer variable length blocks of data between storage units or locations within memory, single commands to carry out multiple operations. So these are some of the important features of CPU. Then coming to the storage point, the storage has two types. One is fast access storage, other is auxiliary storage. Fast access storage is nothing but the number of memory or the blocks of memory which are present on chip. That is your fast access storage. Auxiliary memory is nothing but the secondary memory. In addition to RAM, it is now common to have ROM, PROM, EPROM for the storage of critical code or predefined functions. ROM stands for read-only memory, PROM stands for programmable read-only memory, EPROM stands for electronically programmable read-only memory. So these are some of the types of ROMs. So something, if you want to store permanently, use ROMs. For example, the codes, the important codes, critical parts of the codes or the predefined functions, if you want to store, you can store it in ROMs. The use of ROM has eased the problem of memory protection to prevent loss of programs through power failure. So once earlier days when the power went off, whatever programming was done, whatever the system was performing was lost. Now because of the ROM, where we have stopped, is at the same point we can start the function. That is, memory protection problem has been reduced, or it has been solved. It has been solved. An alternative to ROM is the use of memory mapping technique. The trap of that trap the information or the instruction which attempt to store the protected area. So these are some of the storage concepts. Then nowadays we use a methodology called as DMA, direct memory access. For efficiency of transfer, it is sensible to transfer large blocks of data rather than a single word or byte. So this is some of the important points of the storage. Next thing is input and output. What are the inputs required? What are the outputs to be used, or what are the outputs to be employed? So these are some of the important concepts of input output. So if I come across the most of the computer control systems, input output can be classified into three sections. First one is process input output, operator input output, then the computer input output. The next is bus. What is bus? Bus is not your JNC bus. It is the group of conductors. It is a collection of conductors. Which carry the electrical signals. Buses are nothing but they are the group of conductors. Buses are characterized in three ways. First one is mechanical or structural bus, electrical bus. The third one is functional bus. The physical form of bus represents the mechanical characteristics of the bus system. The electrical characteristics of the bus are the signal levels, loading, and type of the output gates. The functional characteristics describe the types of information which the electrical signals flowing along the bus conductors represent. The bus lines can be divided into further three functional groups. One is address lines, data lines, control and status lines. This is about your general purpose computers. In the next class, we'll be dealing with single chip microcomputers and microcontrollers. Okay, if there are any doubts, you can unmute and you can speak, or else we'll wind up. Okay, no doubts. Thank you. Please mark your attendance on the chat window. If everything is done, I'll end the class. Meet you in the next class. Thank you very much.